Hi everyone, in this video we're going to learn about inequality. So recall how we talked about solving equations before. An equation typically has an equality, right? So we're going to switch things a little bit and see that if you pick any two numbers in your head, one of these things will happen, right? Either one is less or they are equal, or one of them is larger or one is greater. For example, if I pick 4 and 4, then they are equal. If I pick 2 and 4, 2 is less than, and if I pick 4 and 6, then 6 is greater than. So one way to encapsulate this information is to say that let's call these numbers x and y. All right, that means that the three things that can happen is x is less than y, or x is equal to y, or x is greater than y. That's the case which is an equality, and these are the cases where it's called an inequality. Now we've seen that these things, when it comes to numbers, can be represented on the number line. So what does this mean? This means that if y is here, then x is less than y, meaning x can be anywhere to the left of y. Okay, so x is to the left of y. Whereas if I know x is larger than y, that means x is to the right of y. Okay, so that's what these things mean on the number line. Now when it comes to solving these, the rules of algebra remain the same, meaning we still use inverse operations on both sides. So just as you would do with an equality, I'm going to add 3 and then divide by 2 to get x less than equal to 4. Another way to represent the solution is on the number line, just as we saw. This means what this says is x is any number less than or equal to 4, which consequently we've seen on the number line means if I take the number 4, it is everything to the left of 4. Now the question is, what about 4? So let's check. Is 4 less than equal to 4? The answer is yes, because 4 equals 4. Which means 4 is going to be included in our solution, and to do that we use a solid dot to indicate that 4 is included. Okay, so this brings us to the idea of solid dots and hollow dots. So essentially, for example, that signifies x less than 4. Yeah, so 4 not included, you would use a hollow dot. Whereas if 4 or any number for that matter is included, you would use a solid dot. Now over here when we solve, we implicitly assume certain rules, and let's be more explicit about those rules here. These are operations that can be performed on inequalities. For example, adding, subtracting doesn't change anything. To say that a is less than b, then a plus c is less than b plus c. For example, if I start by saying, I want blue, so 2 is less than 4, then 2 plus 5 is still going to be less than 4 plus 5, right? Because that's 7 and 9. Similarly, 2 minus 7 is going to be less than 4 minus 7 because that's negative 5 and that's negative 3. Why is this true on the number line? You can reason it out. If A is less than B, that means A is to the left of B. But if I add the same number to both A and to B, these new numbers A plus C and B plus C, the A plus C is still going to be to the left. Similarly, if I subtract the same quantity from A and the same quantity from B, and I make them A minus C, and B minus C, this is still going to be to the left of B minus C. So the relation less than is preserved. Symmetrically, this is going to be true even if we talk about greater than sign. But when it comes to multiply and divide, we have to be a little careful. If you multiply and divide by a positive number, then the behavior is as expected. Meaning, if I take two positive numbers, say 2 and 4, and these are less than, right? So 2 is to the left. If I times this by 2, it goes to 4. And if I times this by 2, this goes to 8. So there's still the 4 is still to the left of 8. Or if I half, so if I divide by 2, then this goes to 1, and if I divide by 2, this goes to 2, but they still have the left, right, the direction is preserved. However, if you multiply by a negative, that's no longer the case. Let's see why. For example, I know 2 is less than 4 on the number line, but if I let's say multiply by negative 1, then this is now negative 2 and this is negative 4. So to say negative 2 is less than negative 4, that would be wrong because that's not true. Instead, you have negative 4 is less than negative 2. Okay, so multiplying and dividing by negative, you have to be careful about the direction of the inequality. So the negative flips because of the behavior of the number line, meaning on the number line, it increases to the right, but it decreases to the left. So anything that's more to the left in the negative is smaller, right? So what happens is when you take a larger number and you make it negative, it becomes much more negative than if you take a smaller number and then you make it negative. Okay, so just be careful when you work with negative, when you're multiplying or dividing by negative things. Let's look at this example, which will be the last one for this video. So we go about solving in the regular way. I eliminate the 1, making this 9. And now, when I eliminate by dividing, I have to make sure that I flip the sign. Okay, so here the greater than became a less than. And that's because I was dividing by a negative number. And I can represent my answer this way, or I can say it's negative 4.5 less than that, not including negative 4.5. Okay, or. And later on we are going to learn another notation. But that's the end of this video, and next video we're going to look at a little more complicated example.